All right, page 178 in your textbooks, and your homework last night was to practice what we did in class yesterday, practicing with adding polynomials, subtracting polynomials. Of course, we don't ever really subtract polynomials. What do, Adam?
Add the inverse.
Yes, that is correct. We add the inverse. And when it comes to adding in general, we said we can only combine terms, class, that are like to each other. I recommended that as we write our answers or as we write our problems, make the terms, put the terms in what kind of order, Joshua? Descending order, meaning the biggest power first, and then the next biggest power, next biggest power, next biggest power. And so forth there. So on page 178, number 14, what did you get when you added those polynomials together, Dylan?
11x negative 3.
Very good, 11x negative 3. Number 16, what did you get, Adam?
6b squared negative 13b negative 1.
Great job. By the way, notice the descending order there. The p is squared, then the p to the first, then the p is gone. Looking at number 17. Or number 18, excuse me. What did you get for that one, Lana?
4y squared positive 5y negative 1.
Good. There were no terms that were like to the 4y squared, but the other terms had like terms. By the way, that first polynomial, what would we call it, class?
Trinomial?
A trinomial. They're on number 18. It starts with a trinomial, and then to the trinomial we add a binomial, right? Number 20. What did you get when you added those together there, Joshua?
5x cubed positive 3x squared positive 6x positive 3.
Good job. 5x cubed positive 3x squared positive 6x positive 3. By the way, number 20, the first polynomial, what is the degree of that polynomial, class? 3, because the highest degreed term is a third degree term. What about the second polynomial? What's its degree? Second degree polynomial. So a couple of trinomials there, but different degrees because they have different powers represented there. Number 22, when you combined all the like terms together, what did you end up with for your answer, Dylan?
10x positive 8ax positive 2a.
2/3 correct. Adam? Number 22, what was your answer? Read it.
I can't find 22.
Can't find 22. That could be a problem.
14, 16, 18, 20, and then it goes to 8.
So you skipped the 22, 24, 26, 28. That is issue. All right, Lana, what did you get for number 22?
Another one.
Wait, 22.
22 even?
Said 14 to 28 even, and then 8 to 20 to even. On the next page. Joshua, what did you get for number 22?
No, I didn't get anything for 22.
10x positive 8ax negative 9.
There we go, negative 9a at the end. The 10x, positive 8ax, negative 9a, unless you want to put the highest degree term first to get the descending order, in which case, which term has the highest degree, Joshua? The 8ax has the highest degree, so I would have maybe led with that, then maybe the positive 10x, and then the negative 9a.
22, I think.
All right, number 24, Lana, what did you get for that answer?
8x negative 17y negative 15z.
Again, 2/3 correct. Let's see if Dylan can bail you out.
6x negative 17y negative 17z.
Also 2/3 correct. Let's go to Joshua. What did you get for number 24?
I got 6x negative 17y negative 22z.
Ooh, all right. Should have been a 6x, negative 17y, negative 15z. Let's take a look at it very quickly. And when it's really big like this, again, in my case, I would probably just circle, underline, box, squiggle, underline, arrow, whatever. But if I'm going to have to write it on the chalkboard anyway, I'm going to go ahead and put it in columns. So I'm going to put the positive in front of the 5x. I've got the negative 10y, the positive 3y right below that, a negative 7z, another positive 5x, another negative 10y, a negative 3z, a negative 11x, a positive 4z, a positive 7x, and a negative 9z. Okay? If I'm going to write them down, I might as well put them in columns, right? And remember, within each column, get your like signs together first. So I group all the positives, 5, 5, and 7 class. That's a positive 17x. Put that with the negative 11x. There's the 6x. Here, I'm going to put the two negatives together first. Negative 20y. Put that with a positive 3y. There's the negative 17y. Here I'm going to put all the negatives together first. 7, 3, and 9.
19z.
Negative 19z. Put that with a positive 4z to get negative 15z. But again, if you'll group like signs first, it'll make your work a little bit more accurate. And there is something to be said for writing columns. It probably makes your work more accurate. I'm just usually too lazy to actually do it. When it's already in the book for me, I usually just circle, underline, box.
How did I get
whatever.
8x at the beginning?
No idea. All right, let's take a look at the next one, number 26. And had a little distribution to do first into these polynomials. Lana, what was your final answer on 26?
Negative 4x squared, negative 1, positive 2x.
Good, and I would arrange that in descending order though. So your answer was not wrong. She said negative 4x squared, negative 1, positive 2x. But Lana, the best way to write the answer would be?
Negative 4x squared, positive 2x, negative 1.
There we go. Just move that 2x after the x squared, so that way we have that descending order there.
5 at the end instead of negative.
All right, so when you distributed, the 2 times x gave 2x, 2 times negative 3.5 should have been negative 7.
Okay.
All right, then you distribute the 4. 4 times 1.5 is positive 6. And then 4 times x squared is negative, or the negative x squared is negative 4x
That's why
squared.
I messed up. I thought it was like asking half of 4. So I
No, 1.5 of 4. So half of 4 is 2, but it's half again. So 1.5 of 4 would be 6. Or 4 times 1.5, 6.0, if you want to use the decimal there. All right, then number 28, we'll go back to Dylan. What'd you get on this one?
11x squared, positive x, negative 39.
Good, 11x squared to positive x, negative 39 is correct. All right, questions on any of these? Questions?
For 26, you swap it with the negative one.
I just put the 2x before the negative 1, so that way we have x squared. X to the first, and then technically x to the nothing, x to the 0 power. We just, because that's 1, we just don't write it at all, but technically it's there, right? Good. Any other questions on these? By the way, what is the degree of an individual term? How do I find the degree of an individual term, Adam? For instance, if I had a 6x cubed y to the 4th, how would I find the degree of that term?
Add the things on the top.
What do we call those things on the top? Exponents, yeah, powers or exponents. Don't listen to Lana. Exponents or powers, I guess, is actually acceptable. So what would be the degree of this particular term?
7.
This would be a 7th degree term. And of course, we said for the polynomial already, whatever degree term is the highest in the polynomial, that is the degree of the
When
polynomial.
you have like maybe 3 terms and you're trying to find the highest. What do you do with that?
So in this case here, you would say, well, this is 7th degree, this is 10th degree, and this is
8. No, 9th degree.
good. Don't forget that's a 1. So this is 9th degree. So what's the degree of the polynomial? 10th. And this is why we typically want descending order. So that way the highest degree term comes first. And that way you can look right at the first term and already know the degree. That's the point. That's part of the point of descending order. It's not certainly not the only reason. We're going to see even more important reasons later. But it definitely helps you to, Now, I will say this. If you're going for descending degree of x, the x is cubed squared first, right? So this could be descending order if you're looking just at the x. But if you're, going for descending order overall, that's one of the advantages of putting the highest degree term first. Okay, that said, usually when we name descending order in this class, there's only going to be the one letter to worry about anyway, frankly. So, all right, turning over to page 181. Turning over to page 181, and you did 8 through 20, the evens here, and subtracting or adding the inverse. Number 8, what did you get for your answer, Joshua?
3x squared, positive 4x, positive 4.
That is correct. Number 10, Lana.
5a, positive 7.
Great job, 5a, positive 7. Number 12, Adam.
2x negative 1.
2x negative 1. Number 8, again, in case you couldn't hear him, 3x squared, positive 4x, positive 4. Number 14, Dylan.
2n squared, positive 8n, positive 8.
Great job, 2n squared, positive 8n, positive 8. Number 16, what did you get? Back to Adam.
7x cubed positive 3x squared.
That's number 15. How about number 16?
It's 7x, wait,
That's 15.
that's number 15?
That's number 15. Look in your textbook.
Oh,
Yeah. We want number 16. This one right here. Maybe he did the wrong one there. Let's go to Dylan. Back to you for number 16.
X squared positive 2x negative 6.
Ooh. Remember when you add the inverse, change every sign, including the very first one. You just forgot to change that first sign, Lana.
Oh.
Wait,
Number 16.
11x squared positive 2x negative 6.
There we go. 11x squared positive 2x negative 6. Make sure we change that 5x squared to a positive that adds to the 6x squared. Let's go back to Adam for 18. What did you get on that?
5x to the fourth negative 7x squared negative 8x cubed.
Hmm.
Did I do something?
Let's go to Joshua.
5x to the fourth negative 2x cubed negative 7x squared positive 11.
That is correct. 5x to the fourth negative 2x cubed negative 7x squared positive 11. Let's take a look at this real quick, Adam, because the problem here is these terms are not lining up, are they? The first polynomial, that trinomial, is in descending order. The second one isn't. And so if you're just looking at matching up terms, it doesn't line up. So I've got a 3x to the fourth, then I've got a negative 7x squared. Notice I'm going to leave a little bit of a gap for the cube power. Then we've got a positive 8. I'm going to leave a little gap for the first power. Then I've got to change all the signs. So it's not a 2x cubed now. It's a negative 2x cubed. It's not a negative 2x to the fourth. It's a positive 2x to the fourth. It's not a negative 3. It's a positive 3. And now when I add them together, there's the 5x to the fourth, the negative 2x cubed, the negative 7x squared, and the positive 11 in descending order. Yes, sir.
I figured out what I did.
Okay.
Accidentally mixed up the last part of 17 with 18.
Yeah, don't do that, Adam. All right, so for redemption, number 20, third tries the charm, Adam. What did you get?
Negative 4x squared positive 4x cubed negative 3x positive 7.
That is correct, but let's rearrange it so it's in descending order.
Positive 4x cubed negative 4x squared negative 3x positive 7.
There we go. 4x cubed, negative 4x squared, negative 3x, positive 7 is the best way
Would it be
to write that
wrong?
answer. It's not wrong the other way, no, but because I know what's coming very soon, really helps to have it in descending order. So that's why I'm kind of pounding that point now. I didn't pound it earlier. Now I'm pounding it because of what's about to happen. So, boom, boom, boom.
Oh no.
All right, questions on this?
Wait, test tomorrow.
No, exam next week, but anyway.
Oh. There's a test this Friday.
No.
Test this Friday.
We just had a test.
I don't know what he's talking about. Don't listen to Dylan, don't listen to Dylan. I said, you can tell I say don't listen to Brandon a lot, can't you? I say that all the time, so it just slipped off the tongue. Like, who am I always saying not to listen to? Brandon. So, sorry, unintentional mistake there. All right, Scott, you can ask Gavin about Brandon. He knows all about Brandon. All right.
Wait, you done?
Gavin's watching Algebra 2, so
Oh.
Brandon's in Algebra 2.
Oh.
I pick on Brandon a lot. It's fun to pick on Brandon.
Scotty.
All right. All right, let's go ahead and take a look at a word problem. So you can set your books aside for just a moment. And let's come on over here. Take a look at a word problem together. And let's have Lana read this problem for us, if you would, please.
James and Catherine together have 1,900 in savings. James has 300 more than 3 times the amount that Catherine has. How many do they each have?
How much does each have? We're really struggling to read today. All right, I picked the wrong person for this.
How much does each have?
All right, so presumably maybe these are siblings. Maybe James is older, okay? And so he's had more time for, maybe he gets money at birthdays and Christmas, and maybe parents are wise, and instead of saying, here, spend all this, and then he graduates high school and has no money, maybe he has been putting money away in savings, or maybe he's older and has a job, and Catherine's a little younger, doesn't have a job, so he's making money and putting it into savings so he can save for college, so he can afford to pay for it. But anyway, we don't know all the backstory here, but we know in order to solve the word problem, we always start by finding, class, how many unknowns. And Lana?
2.
2. And they are?
J and K.
J and K. And she's not just kidding about that either. They really are J and K. And who gets to be X? He just got that. He's a little slow. Who gets to be X here, Lana?
K.
Okay, James has $300 more than 3 times the amount Catherine has. It comes back to Catherine. Catherine gets to be X. How would that represent the amount of money that James has?
3x plus 300.
Good. How many were thinking the same thing that Lana said? 3x plus 300. He has $300 more than 3 times the amount Catherine has. So 3 times the amount would be 3x, but he has 300 more than that. Questions on the initial setup? All right, now we got to find the number we haven't used yet, Adam.
1900.
1900. Who has 1900, James or Catherine?
It's the total. It's the total.
It's the total. It's what they have together. So what should my equation be, Adam?
3x plus. Where'd you get 3x from?
James has
More than
300
3
more
times.
than 3 times the amount Catherine has.
Okay.
All right, so what's my equation?
3x plus 300. Wait. 4
That's James.
plus x
That's Catherine.
equals 1900.
There we go. And of course, you started to kind of correct yourself there. We could take a shortcut and do the combining all at the beginning class to get 4x plus 300 equals 1900. But hey, if we did it, we'll combine now to get the 4x. And at the same time, let's get rid of this 300 because I don't want to write it down and then get rid of it. I feel I'm too lazy for that.
1500.
What do I do with the 300?
Subtract.
Subtract the both sides to put a negative 300, right?
16.
I get 1600. And now we divide away the 4 to get
400.
400. So who has 400?
Catherine.
Catherine apparently has $400. How much does James have?
1500.
1500. 3 times that would be 1200 plus 300 more. So he has $1500. He's got considerably more than Catherine does. Questions on that word problem? All right, we'll continue looking at a word problem or two every day, moving forward for quite some time. For now, turn over to page 185. For now, turn over to page 185. And I need you to do numbers 9 through 14 at the bottom of the page. Page 185 at the bottom. They're in the review section. Numbers 9 through 14. Take just a few minutes to work on these problems. Questions, sir?
Can we work on them in the book?
Sure. If you've got enough room to be accurate, be my guest. Well, don't really be my guest, just an expression is, have at it. Scott's finished. But does he have them right? That's the question.
Oh,
You can sit there and eat your chicken biscuit while you wait for the rest of us to finish. Sushi roll?
In the morning?
Hopefully not for breakfast. I don't know what they do in Japan.
It's not like they eat sushi.
Probably do.
I don't know.
I mean, I don't eat sushi at all, so I don't.
Me
It's
neither. It's
alright.
nasty.
I don't know the idea of raw
All it is
fish.
fish eggs and nasty.
I don't know all about
That's it. That's what it
that and seaweed.
is. Ugh.
I don't know. Here I'm talking about sushi and I don't even eat the stuff, so I really can't speak
Anything
to
that's
it.
in the water is bait, not food.
Oh.
But bait for what? Other bait?
I don't like fish or I don't like any seafood really.
I'm sorry.
It's
I actually do like seafood. I don't know.
My parents don't like it either, so we never.
Well, you're not done yet, so you work. Scott and I will chat it up, but no, we can't do that, can we? Dylan's finished. I'm sure Dylan does have all the right answers. Scott may want to double check his.
Yes, Scott, double check him.
Shh, I'm the
Does
teacher.
he
I get to
even
have
know
fun. You have to
Scott?
report. He doesn't even know Scott.
Oh.
Nope.
You've never seen him.
If you ever saw him, you'd recognize him. He has 2 eyes, 2 ears, a nose, a mouth, some hair on top.
He's a giraffe.
Yeah.
He's
Oh,
tall.
sorry, Scott.
They probably did hear that.
You probably did.
He's probably gonna beat you
He's
up
gonna be
next time.
sad now, Josh.
Ow.
I don't think he cares what Josh thinks.
He's probably crying eating sushi rolls.
He's probably already fast forwarded through all of this.
Oh. Cue the Jeopardy music.
It'll take about 1 more minute to be finishing up, and then we'll take a look at these together. Pay attention to every sign, every number, making sure you keep track of like terms only, don't miss any terms. If nothing else, algebra teaches attention to detail. Very important. Little things that separate the successful from the failures in life. And algebra helps to cultivate that attention to the detail.
Which one am I? Failure?
Oh, you haven't really started your life hardly yet. You know, you're still in this learning phase. But my goal is that you would be a great success. You used to have gotten a great way. So I want to teach you to be successful. Yes, sir.
Wait, so we're in the learning phase?
Very much.
But then after college, we're in the forgetting phase?
I guess. All right, let's go ahead. Very much. All right, let's go ahead and take a look at these together. Number 9. Speaking of forgetting phase, Adam, what did you get on number 9? I forgot.
Positive 1x cubed, positive x squared, and negative 1.
Great job.
Oh, it was
Positive x
right.
cubed, positive x squared, negative 1. First try was the charm. Number 10, Lana.
Okay. 5x cubed, positive 2x squared, positive. What? Negative 9x, positive 2.
There we go. 5x cubed, positive 2x squared, negative 9x, positive 2. Good job putting that in descending order. Number 11, Joshua.
6a squared positive 2a negative 16.
Fantastic. 6a squared, positive 2a, negative 16. Number 12, Dylan.
4x to the 4th negative 3x cubed negative 2x squared negative 2x.
Adam?
Positive 4x to the 4th, negative 3x cubed, positive 6x squared, negative 6x.
Yeah, it should have been a positive 6x squared, negative 6x there at the end. So again, the answer, 4x to the 4th, negative 3x cubed, positive 6x squared, negative 6x. Dylan, Dylan, as you look at this problem and see the two x squares, remember we're subtracting, so we add the inverse. And this time you changed the sign of the first one to make it a negative 3x cubed, but you forgot to change the next sign to make it a positive 4x squared, which would have given you the 6x squared. And you forgot to change the next sign to a negative 2x, which with the negative 4x gives negative 6x. So make sure we change all the signs. Let's go back to you on number 13 and see how you did on this one.
X squared negative 3, no, x cubed negative 3y cubed negative 12xy squared negative 6x squared y.
Close. Let's see. Now, let me have you say, I think you said it. You had an x cubed, which was right. You had a negative 3y cubed, which was right. You had a negative 12xy squared, which was correct. And there was just the x squared y term that was off. So let's look at our x squared y's. We have a positive 1 x squared y at the beginning. And then if we change the signs, it gives us a positive 8. Or excuse me, a positive 7 x squared y, which adds together to give us a positive 8 x squared y in our answer. Now, one little detail here. What's the degree of the first term, class?
3.
3. What about this term?
3.
What about this term?
2.
3.
3. What about this term?
3.
Also 3. They're all third degree. So we really can't put a descending order based on degree of term. So we're going to have to pick a letter and roll with that one. Do you want to pick x or y?
Y.
All right, so let's descend the y. What should be the first term if we're going to descend the y?
Negative 3y
Cubed. Then?
negative 12xy squared
Then?
positive 8x squared y
And then?
positive x.
And by the way, I want you to notice, and this will often be the case, class, that as one letter descends, cubed, squared, first, gone, the other letter will ascend. Gone, first, squared, cubed.
Wait a minute.
So you have a
My-
descending, ascending order. You're going to see that a lot in algebra as we work with various
My answer
polynomials.
was the other way around.
Yeah, and you could, if you descended the x, this would have been the first term, second term, third term, fourth term, right? It just
Yeah.
depends on the order in which you wrote it. And then number 14. Let's go back to Lana. What did you get?
17x to the fourth negative x cubed negative x positive 6.
Really close. Only one tiny change. Joshua?
17x to the 4 negative x cubed positive x positive 6.
Yeah, it should have been a positive x. So I'm looking through for my x's, and there's actually only a single x, and it's in the very last polynomial, and it's a negative x, but there's a subtraction before it, which should have changed it to a positive x. So 17x to the fourth, negative x cubed, positive x, positive 6. Should have been our answer there.
Number 9.
Number 9 again was x cubed, positive x squared, negative 1.
Yeah,
I
when you
did
said
get
it,
that
it
right.
just sounded weird.
All right, questions on any of these? Anyone 6 for 6?
I
No good one?
got 2 of them wrong.
All right, so 4 out of 6. Anyone 5 out of 6? Just missed 1.
Yeah,
Hi, Joshua,
number
just missed the
13,
one.
I forgot
Dylan?
a term.
I missed 2.
All right, just missed a couple.
3 out of 6.
Half of them. Okay, do we understand the things we missed?
Normally most of it was just with the negatives, not putting
Changing
I was
all
just being
the signs,
careless
right?
then.
All right, well, clear your desk except for a clean sheet of paper and a pencil. Clear your desk except for a clean sheet of paper and a pencil and everything else away. And now let's put a little pressure on you to do well. We practiced it a few times, should have it down pretty well now. So let's put it to the test, or put it to the quiz. And we're going to take quiz 8. Quiz 8. So Scott, clear your area, and except for a clean sheet of paper and a pencil as well. Cheat sheet aside. But God is watching. All right.
Put your coffee aside.
So you don't spill on the things. Anyway, all right, first last name at the top of your paper along with today's date. First and last name at the top of your paper along with today's date, which is 9/30/21, the last day of September.
Oh,
9/30/21, today's date.
did it go by so fast?
Almost October.
It'll
And let's take a look at the quiz together very quickly, and then I'll have you get started. Numbers 1 through 3, you're telling me what that thing is. Numbers 4 and 5, all you're doing is rearranging. 6 through 9, you're adding or subtracting. I'm not sure why there's not a period after the 6, like there are on all the other numbers. And then number 10, solving a word problem by setting up an equation. All right, you may begin. No, actually, that's a very old word problem. That's from years ago. It's actually named in honor of our 6th grade teacher who used to be here and his wife. But before they even came to teach here, because we were friends from college, so the word problem was written, just they'd gotten married, I wrote the word problem, and then he ended up coming to teach here, so years later. Anyway, get started. Not you, Josh. Unless maybe you'll marry a Sarah one day, I don't know. Probably doubt it.
No problem.
Out of all the names in the world,
Sarah.
the likelihood is pretty small. Anyway. Use a quiz copy as a cover sheet. Do not mark or write on quiz copy. Just using that as a cover sheet. I'm too lazy and don't want to reprint any of these for next year.
Oh, you just
That's the whole point. I don't have to tear anything out. I don't have to print anything. I just hand back the same every year. Because I'm lazy.
except the test.
Except the test, I do have to print those. See, I told you, I'm consistent. I am lazy in everything. I guess, Scott, you could write on yours, I suppose, because I don't want you to mail it back or anything, so.
See all those diseases?
Affected with coronavirus. Still have a couple more minutes to be finishing up. Just a little bit longer to be finishing up. All right, one more minute. Those from at this time. All right. I'll work a little bit quicker next time. All right. As long as you got most of the work done, you get most of the credit. Next section in your notes. Next section in your notes. Multiplying monomials. Multiplying monomials. Multiplying monomials. And let's start with some really basic monomials, like a monomial that's just a letter, like for instance, a squared. And if I wanted to multiply something like a squared times something like a cubed, well, remember, what is a squared, class?
A squared. A times
A times A. And what is a cubed?
A times A.
So if I multiply A times A times A times A times A, that's A times A times A times A times A. Or in other words, class, we would say that's
A to the fifth.
A to the fifth. So clearly multiplying A squared times A cubed gives A to the fifth. What if I did X times an X squared? We'll make this a little easier. Well, obviously, we have X times, well, what is X squared?
X times
X times X, which X times X times X is
X.
X cubed. Well, that means that X times X squared is X cubed. Notice what we're doing with the exponents. A squared times A cubed, A to the fifth. X to the first. X squared, X cubed. What are we doing here, class? Adding the exponents. Write that in your notes if you would. To multiply like bases, add the exponents. To multiply like bases, add the exponents. To multiply like bases, add the exponents. Now, why do I say like bases? Because what do you get if you multiply an x times a y? xy, right? There is nothing squared because there's not two of anything. It's just xy, right? We don't add those exponents because they're not like bases. But a's are like bases, x's are like bases to each other. So say this with me, class. To multiply like bases, add the exponents. But what about monomials in general? Something like, for instance, maybe a 3a squared and a 5a cubed. Well, what if I wanted to multiply those together? 3 steps that you need to know to multiply monomials. Step number 1, sign. Step number 2, number. And step number 3, letter. Or letters.
I
Want to go
remember
plural.
this.
Sign, number, letters. And Lana's having flashbacks to pre-algebra. 3 steps to multiplying monomials. Sign, number, letters. Sign, very straightforward. There's 2 rules. If the signs are the same, you get a positive. If the signs are different, you get a negative. And that should also sound very familiar. We did that earlier this year with signed numbers. Now we're going to do that with signed monomials. Sign, number, letters. As far as the numbers, you just multiply. And as far as the letters go, well, add the exponents if they're like bases. To multiply like bases, add the exponents. So if I were multiplying a 3a squared times a 5a cubed, both signs are understood positives. And if their signs are the same, class, you get a positive. And then we multiply the numbers. We just multiply 3 times 5. 15. And to multiply like bases, class, we add the exponents. So a squared times a cubed gives a to the 5th power. Easy enough? What if it were a negative 3a squared b and a positive 5a cubed b to the 4th? Well, now, same thing, sign, number, letter. The signs now are different, class, so now we would get a negative. But 3 times 5 is still 15. We still multiply the a squared by its like base a cubed to get a to the 5th. But we multiply this b by its like base b to the 4th to get b to the 5th. And there's our answer. Okay. Write this example down if you would, please. Negative 4xy cubed times negative 2x squared yz. And we're going to multiply these monomials together. Using what 3 steps, class?
Sign, number.
Sign, number, letters. And the signs are the same, so class?
Change.
Since the signs are the same, we get a
Positive.
Make sure you think about what I'm asking. 4 times 2, 8. And then to multiply like bases, class, add the exponents. So this x is a like base to x squared. So we add the exponents, we get
X cubed.
x cubed. Remember, this is an exponent of 1. This y cubed is a like base to the y. So we add the exponents to get y to the 4th. And this z is a like base to nothing. But it still exists, right? Just because it has no friends doesn't mean it doesn't exist. Just keep the z. And there's our answer. Lana evidently remembers this from last year. Josh, you remember this from last year also? You gentlemen have learned this before, I trust. You never have.
I don't know.
You don't remember this from last year? Okay, does it make sense to you?
Possible.
Any questions on this, gentlemen? All right, you two good to go? All right.
Oh, I did learn this.
You did learn this last year? Okay, questions on the sign, number, letter. Turn in your textbooks now to page 185. And on page 185, I want you to numbers 1, 3, 5, and 7 at the top of the page. Page 185, do numbers 1, 3, 5, and 7 at the top of the page. Multiplying sign, number, letters. Lana's finished. Adam's finished. Scott's finished. Good job, you guys beat Scott. He's screaming at the computer. No, they didn't. Hey. We're in different time zones, so mathematically, mathematically everyone beat you because we did this before you could watch it because we're recording. All right, anyway, I'm just
But
picking
when
on
he did watch it, he probably did do it.
I don't know. Well, there's no way to know. All right. Well, I guess he could have him on. Please email him. Let him know that Scott doesn't care that much. I don't think. Maybe he's that competitive. I don't know.
Yes.
I'm that competitive. All right. Number one. What did you get for your answer, Dylan?
8x cubed.
8x cubed is correct. Number three. What did you get, Adam?
10x to the fourth.
10x to the fourth. Number six, Lana. Actually, number five, Lana.
Oh, 4x cubed y to the fourth.
4x cubed y to the fourth. And number 8, Joshua. Or 7, Joshua. I don't know why I'm looking at evens. I said odds. Number 7, Joshua.
I was there 15, a to the 5th, b to the 8th.
Positive 15, a to the 5th, b to the 8th. Questions on this? Do we go 4 for 4? Question?
Simple mistake.
Okay, which one?
Just accidentally forgot to put a positive 15.
Okay, remember, if the signs are the same, automatic positive, they're different, automatic negative. You'll practice just a little bit with this for homework tonight. For homework, need you to do page 185, the practice 2 through 8 even, the ones I kept for some reason trying to call on you for. Back on page 181, I need you to do the review 11 through 14. And then back on page 91, a couple of word problems for you to do, numbers 51 and 53. So page 185, the practice, numbers 2 to 8, the even, page 181, the review, 11 through 14, and page 91, the word problems, 51 and 53. Adam, don't forget to do 22, 24, 26, 28, back on page 179.
179.
Page 179, 22 to 28 even.
22, 28.
All right. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.